Hello guys, welcome to Staad tutorials. In this session I will be discussing many steel structures as shown in the figure. As you can see these two, and we will be discussing these two. So let us begin with this one. Initially start Pro, select new project, select truss, give it a name. As per our figure, the units are pounds and feet. So select foot and pounds, select next, select OK, select add beam finish, select front view. Well, as per our figure, first we have 8 feet, so select 8 feet. However, height is 12 feet, so we might require to edit it. Select 20, or else you can select 15. So as per our figure, there are no nodes in the middle, but however during height you have nodes at a gap of 3 feet interval. So let us start till 8 feet and then interval of 3 feet, 3 feet, 3 feet and 3 feet, and then as per our figure you can see exactly at 3 feet nodes you need to cut it down. So in this way you connect the both two. Then once again, since you have from here and here, now you can switch off the grid and select the entire structure, go to geometry, intersect the members so as to get the new beams. As you can see, new beams are created. So now you just delete the outside beams so as to get a structure near to our figure. You can see they are bending downside, so using add beam point to point, you add beams. So in this way our figure is done. Now this is roller support and this is pin support. So go to general property, define, assign profile, angle, add, close, assign it to the entire structure. Then go to support, select pin, create pin support as well as fixed butt, which means roller support. Then assign the support as shown in the figure. Then going to loads, select load case 1, and as you can see in our figure we have nodal loads in x direction. They are 4000, 6000, 8000 and 10,000. So select nodal load fx direction. Since the direction is this side in the x, so it is positive, so we select 4000 pounds, 6000 pounds, 8000 pounds, 10,000 pounds. Now assign it to the structure as shown in the figure. Then final one to the final node. Now scale the loads. Fine. Now you go to design, commands, select check code and take off. Assign those to the entire structure. Now you can analyze it. Since we need to provide Indian code, so we'll delete these commands. Go to design tab, select IS800. Now select commands, check code and take off. Assign those commands to the entire structure. Then you can analyze it. The code we have took it in a wrong way. Select IS800. Now select commands. You need to select Indian code as per your requirements. Then you can analyze it. See, it runs. Now go to select by specification all failed beams. So there are no failed beams. Then you can go to post processing and select the deflection. As you can see, the deflection is in this way. You can even view the value for the deflection. See, well, there is no requirement to go to design tab and do this select again in commands. So in this way we are done with the first one. Now going to second one, you can see this is 5 feet and here it is 6 feet height. So go to file, select new truss, hit name. Well, coming to units are pounds and feet. So select feet and pounds. Select front view. As per our figure, we have 5 feet beam with no nodes in the middle and a height of 5 feet too. So let us select 5 feet to 5 feet. Well, you can see at a 6 feet height and at a 4 feet horizontal distance from this node. 4 feet horizontal distance and 6 feet vertical distance, and as per our figure it ends just right here. So now you can switch off the grade. Well, this is exact our figure with the loads and supports. Go to property, define, assign profile, add, close, assign to the entire structure, then go to support, select create support pinned, then fixed but. Now assign this support to the bottom nodes and the other one to the other node. Then going to loads, select load case 1, and you can see the nodal loads are provided in fy direction and fx direction, which is one is 5000 and another one is 4000. So select nodal load minus 5000. Since it is in downward direction, our positive axis exists in upward direction, and the other one is 4000 in fx direction. Since x direction, the direction is this side, so we need positive. Now assign to the nodes, scale the nodes so you can view it in figure. Now go to design, select IS code 800, verify it, select commands check code and take off, then select check code and assign it to the entire structure. Same for steel takeoff. Then go to analysis, run analysis. You can go to select by specification all failed beams. Since there are no failed beams and the angle is L4046, you can go to post processing. You can view the deflection in this way. So this is the end of this diagram. Now going to the next one, this figure. Select new truss, give it some name, and coming to units, they are in pounds and feet. Select to front view. Well, you can see 3 base of 4 feet and height of 9 feet. So we need to edit to get 12 feet, 3 base of 3 feet. Sorry, it's 3 base of 12 feet. 3 base of 4 feet. Then comes is 9 feet. Then as per our figure, it ends at the initial point. Now exactly as we did before, switch off the grid, and select the structure, intersect those members, then delete the outside members. Then you can go to geometry, select add beam point to point, so in this our figure is done. However, to view the dimensions, you can select dimensions icon here and select dimensions to view display. You can view 3 feet, 6 feet, 9 feet as exactly in our figure. However, later on you can remove those. Now going to figure, it's a roller support here and it's a pinned support on the other side. So go to general, property, define, as usual assign profile, assigning it to the entire structure, then going to supports, creating pinned support as well as fixed butt support, which is roller support, then assigning it to the nodes, but you can see here we gave release at MZ and FX. Coming to here, we need to select, as you can see we give FX and MZ release date this point. We need to select FY and MX. Since we selected FX because in X direction no need to act shear force, well we don't require in Y direction. Coming to here and MZ released, it is because you can see there is no torsion type, so in this also it won't be any torsion type. Which is MY, not MX. So that now you're done. You go to loads and definitions, select load case details, add load case 1, select load case 1, then view the loads. You can see 12,000 pounds and 6,000 pounds at 2 nodes in downward direction. So minus 12,000 and minus 6000, assigning 12,000 to the node, then 6000 also to the particular node as shown in the figure. Scaling the loads, going to design, selecting the particular IS code, commands, check code and take off. Assigning those commands to the particular figure, then analyzing it. Now go to select by specification all failed beams. Since there are no failed beams, you can go to post processing and view the deflection. So you can see the deflection is this way because due to the loads acting downwards. So in this way we are done with the top figure. Now going to the next figure, you can see there is a roller support. How we did a mistake, we need to apply pinned support here and a roller support here. So we'll be changing that by going to modeling, general supports, selecting pinned support and assigning to that node. But pinned support isn't editable. Okay, no problem. Now going to, before that we'll edit this load, changing its direction to fx and mz. Now assigning to the particular node. Now once again analyzing it. Now going to select by specification all failed beams. Since there are no failed beams, you can go to post processing and view the deflection. So you can see the deflection is going to be in this way. In this way we are done with the top figure. Now going to the bottom figure, select new, select truss, select name, and the units are feet and pounds. So select feet and pounds, select next, select add beam finish. Well, coming to the figure, you can see 4 feet base 3, and at the end of each bay 6 feet height required. So let us do it, which is going to front view, editing it to 12 and exactly 3 base of 4 meter and 6 meters 2 base as shown in figure. Then exactly 3 meters up to the end. Exactly 3 meters top side from this node point to the center as shown in the figure, to the center. So let us keep going. Roller support, pin support and 10,000 pounds, 12,000 pounds. Wait. 12,000 pounds. Fine. No need to consider these two loads. They are not particularly mentioned, specified. However, in figure we have one more beam. You can switch off the grid now. Go to analyze, add beam, point to point. You can add in this way. So which is exactly our figure. Now going to general, as usual define the profile. Now assigning the angle to the whole structure, then going to support, creating pinned support as well as roller support, then assigning pinned support to the one end and roller support to the other end, then going to load case details, adding nodal loads. As you can see in the figure, 10,000 and 12,000 pounds in negative y direction. 10,000 pounds we will require minus 10,000 and minus 12,000 pounds. Now assigning the 10,000 and 12,000 to those particular nodes using node cursor. Scaling the loads. Now going to design, select ISC 800. The commands will be check code and take off. Initially, if any beams get failed, then we will use select command. Analyzing it. Now see, checking if any failed beams. Since there are no failed beams, you can go to post processing for viewing the results. As you can see, the reflection is in this way. And coming to summary, the maximum values are obtained for all those nodes. Reactions are also obtained. Animation can be seen. Reports can be obtained. So this is the end of the session. In next session we will be discussing a few more truss like structures. Then we will be going to a steel structure with rigid joints and an industrial truss and some advanced structures. Thank you.